Welcome back to this series on architectural simplification. Today we'll be looking at how our customers use CockroachDB to simplify their ETL, extract, transform, load architectures. What we'll be working with today is a service that writes data to a system of record, and then there'll be a service which acts as a transformer, which will either extract the data manually from the database via pull or receive push notifications from a queue. It will then transform the data before writing it back to the queue. I'll be using this scenario because I'm already using a queue and polling a database is inefficient. The after scenario will involve a service writing to the system of record, and if the data lends itself nicely to being transformed in the database itself, we can remove the transformer element of the architecture entirely. And what this looks like, an application will write data to the database, which will publish a raw message, i.e. an untransformed message, to our queue. The ETL transformation service will be listening on that queue. It will receive the raw data via message from the queue. It will transform that message and then publish it as a transformed message back onto the queue, which can then be consumed by our application. The after scenario is simpler. The application will write data to the database, which will, at point of publication to the queue, perform the transformation itself by way of CockroachDB's CDC Queries. The message on Kafka can then be consumed by the application again and will take round trip times for both the before and after scenarios. Let's create the infrastructure now. First, I'll launch Kafka or Red Panda, and then I'll create an instance of CockroachDB. I'm using Cockroach Demo for this simply because it provides some CDC niceties over and above what's provided by core functionality. I'll create a table. This will simulate an order line item with an order ID, product ID, customer ID, quantity, price, and timestamp. And it's the timestamp that I'll be transforming simply from a human readable string format to a Unix epoch. I'll enable range feeds, and then I'll create a change feed. This change feed will publish a row from the order line item whenever it gets inserted or updated, and it will publish it onto a topic called raw. Next, I'll run my consumer service and my ETL transformer. And what we're seeing here is the total round trip time. This is the time that it takes the data to be written to the database, transformed by the ETL service, written back to the queue, and then be consumed by the consumer. So we're seeing anywhere from 1.5 seconds to 7.5 seconds. I wouldn't say that's too important. The transformer will receive messages at a regular interval from the queue unless it's polling from the database, at which point you're at the mercy of the polling window. What is actually more important here is this simplification that it gives your architecture. I'll stop that, and without tearing anything down, I'll create a new change feed. This time, I will perform the transformation directly in CDC using CDC Queries. The transformation itself is as simple as a select statement. So instead of performing the conversion of a date to an epoch in the transformation service, I can simply do it in here. I convert the timestamp into an integer, and you'll be able to do that with any kind of transformation that you need. If you need to convert a row to JSON, you can do that as a CDC query. And I'll be pushing that onto a topic called transformed to. If I run the new example, now we're writing data and we're recording the total round trip times from the application writing to the database and then receiving the transformed message from the database over the queue. We are seeing sub-seconds in some cases, but as I said earlier, the round trip time isn't the important bit. The simplification of the architecture is where this pattern really shines. If the transformations you're performing on data are simple enough to be performed by CDC Queries, I'd recommend you consider it instead of using a dedicated transformation service. More often than not, you'll see lower round trip times because there's fewer moving parts, and because there's fewer moving parts, there's less to maintain and less components to potentially go wrong. And finally, because we're not using an external transformation service to modify our data, there's no breach of bounded context, all while still maintaining the ability to filter out messages that you don't care about, and also formatting messages in a way that makes sense to your downstream consumers, JSON, CSV, Avro, or Parquet.